So now we have to learn another concept, effective annual interest rate. Okay, so we have learned the nominal annual interest rate, which is just a common quote, not used in calculation. We have also learned the difference between that and the interest rate per compounding period. Now we are going to learn something new. It's called effective annual interest rate. Okay, so what is the difference between these three concepts? Okay, let's take a look at this example. Suppose that you have $100 invested as a principal for 3 years at a nominal interest rate of 12%, compounded semi-annually. So your R is 12% and compounded semi-annually. Okay, so which means in a year you have to compound it 2 times, right? And the actual interest rate per compounding period is what? So the I% is 12% divided by 2 because you're going to compound that 2 times a year. So 6% is your compounding interest rate. Per half year. Okay, so what is the future equivalent at the end of the 3rd year? Okay, so your cash flow diagram will be, you invested 100, so that's the money going out. So at the present time you have $100 spending, and you got 1, 2, 3 years to go. So what is the future equivalent of this cash flow? Okay, and here, okay, because the cash flow is compounded every half year, so actually on the cash flow diagram, you're gonna have 6 periods. Okay, because you compounded every half year, so for 3 years you compounded 6 times. So you're gonna have first period, which is the first half year, second period, third period, fourth period, 5th period, and the 6th period. So every segment of the time is half year. Okay, and then you can put the I is 6% on this diagram. Okay, so that's how you calculate. You cannot use the R equals to 12% to do the diagram, because we said that's just a common quote. It's not used in calculation. So actually, what we used in this calculation is gonna be the interest rate per compounding period. In this case, it's one compounding period is half year. Okay, so that's why we use 6 time segments instead of 3. All right, and then now we have to calculate the F. So the F is, this is to find out future value given a present value. So it's gonna be P times a factor to find out F given P. I% is 6%. Number of compounding period is 6. So it's 100 times, it's to find the F given P. So this is your column. And number of n is 6, so this is your factor. So it's 1.4185. So it is 141.85. That is your future equivalent value of this cash flow. Okay? And so so now you may want to say, is it true that we couldn't use the R to calculate year by year? Okay, if you want to know this, we can try. Okay, so now let's try to use the R, okay, and to compound it year by year. Let's see what will happen. So if you use R, then because R is annual based, so you are gonna compound it year by year. So you're gonna have 1, 2, 3 segments on the timeline, okay? And you have this 100 at the beginning. And if you say, we just want to use the R to calculate it, and I want to find the future cash flow, okay? So now let's just do the calculation. Still, it's to find out F given P, 12%, number of N is 3. So it's 100 times, go check the factor. So this is the same column, but the number of N is 3. Oh, wait a second. So now you want to use the table of 12%. Well, so this is not the one you want to check. You want to check this table, okay? So I equals to 12%, and this is the column to find out F given P, and number of time is 3. So this is your factor. So 1.4049. So 1.4049. So the future equivalent value is 140.49. Well, you can tell these two values, they are different. Which means it is true that we cannot use the R to calculate. Okay, so this is not working. Then you may wonder, well, what is the effective interest rate per year that can convert this $100 to some future value with the same value? Okay, so that's a good question. So you may wonder, if we really want to convert it year by year or compound it year by year, we have 100 at the beginning, and after 3 years we're gonna have a future value which is 141.85. okay, that's the same as if we use the interest rate per period. Then what is the interest rate which makes it happen? There should be some value of I which can make this conversion happen. Definitely, it's proven mathematically, okay? And if we can find out that I, that special I, that's something we call it effective annual interest rate, okay? So that's just an interest rate. It's also on annual base, but it will convert the present value to the future value, which is equal to if you use the interest rate per compounding period. Okay, so this is your effective annual interest rate. Okay, so now we have learned the nominal annual interest rate R, which is just a saying, it's not used in calculation. we also know how to get the interest rate per compounding period. Okay, that's what you use in calculation. And then we also know there is some interest rate that can make this conversion happen year by year. Okay, and that interest rate is called effective annual interest rate. And how do you calculate that I effective? The effective interest rate, you have a formula to calculate that. So this is the equation you want to use. And I here, we can give it a label E, indicate that this is effective and of course it's annual base. Okay, and it can be calculated by using the I, not the I, by using the R, which is the nominal annual rate, and also the M, which is the number of compounding period per year. Okay, so let's see this example. So we still invest 100 as the principal investment, and the nominal rate is R is 12%, compounded semi-annually, so every year is compounded 2 times, so the capital M is gonna be 2. And so what is the future equivalent at the end of the third year? So if you know the R and M, you can actually calculate the IE, which is 1 plus R over M to the power of M minus 1. Okay, so in this case, R is 12%, and every year it's compounded twice, so M is 2, and M to the power of 2 minus 1. So this will give you 12.36%. So the effective annual interest rate is 12.36, and it is bigger than the R, which is the 12%. Okay, so now you can use this IE to compound the cash flow year by year, and of course you're gonna have the same future equivalent value as using the interest rate of 6% every half year. So let's check if that's the case. Okay, so now you can do it year by year. What is the future cash flow? So F is, to find out F given P I, you want to use the effective one. Okay, number of period is 3, so P is 100, F slash P. Now your effective interest rate is 12.36%, number of periods is 3. Okay, so you don't have a table for the I equals to 12.33%. So you have to use the equation we have learned before. So the equation is, to find out F given P, the equation is P times 1 plus I to the power of N. Okay, so now you have to use 100 times 1 plus I effective to the power of N is 3. So that is 100 times 1 plus 12.36% to the power of 3. Okay, and this will give you 141.85. Look at that. this is the value the same as this one, okay? Which means if you want to calculate something out of a nominal interest rate, you have two options. You can first convert that nominal annual interest rate to the interest rate per compounding period, and then compound it period by period. And that period could be less than 1 year, okay? Another option is you can use the effective annual interest rate and still compound it year by year. You will have the same answer. Okay, so let me summarize it here. So if you have a nominal interest rate, R, you have two options to calculate your future or present or annuity equivalent values. One option is to convert the R to the interest rate per period and compounding period by period. The period could be less than a year. It could be a quarter, it could be a month, it could be a day. That's your first option. The second option is you can use your nominal rate to find out the effective annual interest rate. Okay, so find IE and then compound it year by year. Okay, these two options will give you the same answers. All right, so at last, let's see a real case of nominal interest rate, okay? And how different if you do the calculation using R or if you're using the IE, okay? So usually a credit card company, they will advertise their credit card using the APR. APR is the nominal annual interest rate, okay? So that's just a saying. It's just a quote that every credit card company they use. And it's easy to understand because it's a yearly base and it's everybody use the same concept, so you can compare different credit cards. Okay, but you have to know this APR is not something you can use to calculate. It's not something the credit card company to use to calculate the interest you own them. So if you use the $100 at the beginning of a year, how much you need to pay at the end of that year? So you only have like a 1 year span. Okay, at the beginning you borrowed $100, and at the APR of 15%, how much you need to pay at the end of that 1 year. Okay, if you don't know the nominal interest rate, if you have not learned this class, you simply will guess, okay, I borrowed the 100 at the beginning, and the interest rate is 15% per year. So maybe in the end, I will pay them 100 plus 100 times 15%. So that's gonna be excuse me. So that's gonna be 115 US dollars. If you haven't learned this class, that's gonna be your answer, probably. But actually, it's not 115, okay? If you can try it for your credit card company. It's definitely not 115. So what exactly the amount you need to pay back after 1 year? So you have two options. One option is you use the interest rate per compounding period. Okay, the other option is you use the IE, the effective year annual interest rate. Okay, so now let's use the interest rate per compounding period. So credit card company, they how do they compound? They compound it daily, usually. Okay, so it's compounded daily means every year it's compounded 365 times. Okay, so now what is the interest rate per compounding period? It is 15% over 365. So that is 0.0411%. Okay, and then which means you compounded the company will compound it every day, and the interest rate they used every day is 0.0411%. Okay, but if you use the factor method to calculate the future value, you couldn't find out the table for this special interest rate. So we have to use the equation. So the F is P times 1 plus I to the power of n. That's the equation. So it's P is 100 times 1 plus 0.0411% to the power of 365, because you got 1 year and you have to compound it every day, so you got this number of compounding periods, and that will give you the answer as, if you round it up to $1, that is 116. How come it's so thick? 116. Okay, so actually you have to pay $116 instead of 115. I know the difference is small, just $1, but imagine if you borrowed 1,000, 10,000, that's gonna be a big difference. Okay, so the takeaway is, in reality, you don't want to use the APR or the nominal interest rate to calculate. Okay, and another option is you can use the effective annual interest rate to calculate, to compound it year by year. Okay, use IE% to compound year by year. Okay, in this case you only have 1 year. Okay, but the first thing is you have to calculate the IE. So IE, you want to use that equation. It is 1 plus R over M to the power of M minus 1. So 1 plus R is 15%. M is, because it's compounded every day, so M is 365 to the power of 365 minus 1. Okay? If you do the calculation, the final result is gonna be 6.18%. So that is your IE. And now you can do the compounding year by year. So still you can use the equation method because you don't have the table for such interest rate. So the equation to find out F given P is P times 1 plus IE%. Now you can compound it year by year. So you only have 1 year, right? So the N is 1. Okay, let me just write it here. So P is 100, 1 plus IE is 16.18%, N is year. You only have 1 year. So now, if you round it up to the $1 it's still 116. Okay, so these two methods, they are equal. Okay, they all give you the right answer. So after 1 year, you have to pay the bank, to pay the credit card company 116 instead of 115. All right, so this is all for today. So the nominal interest rate is just a quote, just a common saying. So you don't want to use it for calculation. And then what you want to use is either the I% per compounding period or the effective annual interest rate. Okay, so that's the takeaway. And you also need to remember how do you calculate the IE, the effective annual interest rate, out of the nominal interest rate and how many times you compound every year.